Hey, everybody. It's me, Stephen Feuerstein, back for another round of Feuertips. I think this is number 22. We're going to talk about a really cool feature of PL SQL, Oracle database, and many other relational databases, which are table functions. Before I do that, I don't know about you, but I'm having a pretty hard time not being awfully depressed and angry and sad about what's going on in the world, Afghanistan, climate crises, fires, floods, etc. I'll come back to that at the end in terms of what I think we could all be doing, tying it in with my book and my favorite book and the organizations. But I just like to say how nice it is that we can kind of like fall back into the world of software for all the negative things it does by contributing to all that other stuff. We can just fall back into this nice little world and just enjoy PL SQL for a little while, and SQL and technology and logic when so many people are so illogical today. So let's dive into PL SQL and table functions. Share my screen, please. Alrighty, folks. So as you know, we work with a relational database in Oracle database. And so I can say select star from employees. And it says, oh, that's a table, or it could be a view. And then I see the information in that table. That's really cool. But somewhere along the lines, the really smart folks at Oracle said, wait a minute. What's the difference really between a collection and a table? So a table is a persistent data set sitting inside the database, all the transaction capabilities around it, SQL operations against it. A collection or array in PL SQL is an in-memory structure, though it can actually be stored in tables as well, but it's essentially an in-memory structure in your session that you can construct and manipulate using PL SQL APIs. But the bottom line is that they're rows and columns, just like tables have rows and columns, even if the verbiage we use for collections is often different, like index values and elements in the collection. So it turns out that you can essentially treat, or Oracle SQL will treat, a collection as if it were a relational table. And that's the foundation of table functions. So let's start with that. Then we'll roll into table functions and explore some of the goodies there. So I'm going to create a schema level type called list of names. It's a nested table. You know it's a nested table, not because you see the word nested anywhere, but because it doesn't have the index by clause, which would make it an associative array, which you cannot create as a schema level object in the SQL engine, SQL environment, because it's PL SQL only, but nested tables, no problem. So let's create that type. Then what I'm going to do is populate a variable called big-brained species with list of names, and I'll initialize it with my constructor function. And here are just several of the species that have really big brains. So humans, bonobos. I don't know if you know about bonobos. You should check them out. They're the closest to us in the evolutionary tree or bush or whatever you want to call it, just like chimps, but on a different path. And they're amazingly different from chimps and humans. Free love, matriarchal society, check out bonobos. Gorillas, of course, big brains. Octopuses, we talked about them last week a little bit. Amazing. They have really different brains, really big brains. They have 9 brains in their bodies. And then there are birds. Birds like ravens are enormously intelligent, and they have something called a pallium as opposed to a neocortex. So we're all big on our neocortex stuff, but other creatures have similar analogs in their brains that help them do amazing things. But essentially all mammals have those neocortexes. Okay, so I construct this list. As you can see, it's a single column table essentially with 7 rows. And here's the cool thing. I can then say, select from big brain species as if it were a table. And what I do is tell the SQL engine, hey, consider this collection as if it were a relational table with the table operator. So let's run this. And here's my output. Bonobo, dolphin, et cetera, et cetera. And notice that when I have a single column array, a scalar array, then Oracle automatically generates a column name for us called column_value. I can rename it to whatever I want, and then I can do all sorts of fun things. It's literally just like a table or view I'm querying. So I can select from it, I can order by it, I can add a where clause. So here's that same bunch of data. But now I'm going to say only show me those where the column value, the species name, has an O in it. And that gives us just these 4. I can also, and this is one of the really cool aspects of collections, table operators, and table functions, I can merge or combine my in-session data with my persistent data. So I've got a whole bunch of data in tables. and I've built a collection of data in my application. It could even be through Apex. They have things called Apex collections, which are different from Oracle PL SQL collections. And maybe I'll do a session on that at some point, and the difference between them and when to use them and not use them. But essentially, I can construct these collections in my programs. And then I can say, well, I could insert them into a table so I can do SQL against them, but I don't have to do that. It's expensive, relatively speaking. It's slow, relatively speaking. Then I have to clean it up. So I can simply say, let's do them together. Let's merge them together. So here's a join condition, which doesn't make a lot of sense. But anyway, I can do it. And then I get all this data coming out. So that's pretty cool. I can also define the collection in a package. So here, instead of having it all in my local environment, I'll create it in a package. So there's my list. And then let's run it as a select statement. Even outside of PL SQL, no. So what you see here is nothing new, really. You can't directly reference global or package specification-based variables, whether they're strings, dates, or collections, directly inside SQL. Hopefully that will be fixed soon. But again, if you do it inside PL SQL, no problem. So packaged collections, the same as local collections, as long as the type they're based on is known in the SQL engine. Let's keep going. Oh, and by the way, before I go any further, you can also just access all of this code in Live SQL. If you look up table functions, you'll find a script here and it'll be in the blog. We'll come back to Live SQL in a moment after I show you more fun stuff. Okay, so now let's take a next step up. So we can see now that the Oracle SQL is smart enough to say a collection, it's really just like a table. Let's treat it like a table and query from it, do things with it. But also, what about a function that returns a collection? Why should that be treated differently? And basically, it's not. So now I'm going to take that same data. I'm going to put it inside a function. So every time I call the function, it constructs the array and returns it. And then I can run it. And there it is. So this is now a function, a schema level function. So it's known in the SQL engine, and it runs it, and then it says, okay, you want to treat that as if it were a table. We're good. Let's try it again without the table operator. Then I get an error. So it turns out that you can sometimes, in some circumstances, as a 12.1 or 2, you can leave off the table operator and the SQL engine will still figure out what you want to do, but it's a little bit funky. So for example, this doesn't work, but check this out. That works. So if you put the open and close parens, literally telling the SQL engine, hey, by the way, this is a function, then it can query from it. I don't have an explanation for why it's like that. And you'll see perhaps in the rest of my script or your own playing around with these features that you run into these disturbances in the force that it doesn't seem as consistently applied as it could be. All right, now as I mentioned, when I have a single scalar array, so just a list of strings, a list of dates, a list of numbers, SQL automatically gives us the column value column, which I can rename. But what if I have a more complex structure? For example, what if I have a record and a collection of records? So here's my record. I've got for each species their name and the average size of the species of the, I can't remember if I meant the brains, not the brains. No, this is just the size of the average individual. And then I create an associative array on top of that record. So now I'm using an associative array structure, not a nested table or V-array, at the schema level because it's in my package spec. And then I'll simply return a collection of that type. So I run this code. And again, no problem here. And now what you can see, whoops, or a problem here. I have to do a drop package first because I had previously created a version of it that has a package body. And it didn't, I didn't, it's already there, sorry. I did this morning. So drop the package first. Now I'll create it. Much better. What I want to show you before getting to the functions actually, in more detail, is that I can also now, when I'm using a complex structure like a collection of records, then every field becomes a column. So I can reference them by name directly. Cool. And the same thing I'll show you later on with, let's just go right down to it now, object types. So if I create an object type instead of a record structure, and I can do that at the schema level. So here's my object, name and average size. Here's my nested table on top of that object type. Then I can do the same thing as with record structures using a function. I'll come back to that. Let's go back up here, see if I missed anything. Non-scalar attributes, cool. Okay, now let's switch over to a function. So rather than directly return the variable, what I'm going to do is hide that same logic inside a function in my package. Here it is. And notice I'm using the new qualified expression, which became available in 18C. So I'm putting these into these specific locations in the index. And I got to say, I'm not feeling really good about humans. So they go way down on the bottom. Create my package body. And now I'll try to access, I'll run this. So I'm going to call this function inside my query, inside PL SQL. And oddly enough, sorry, that doesn't work. So again, you're going to run into these little disturbances where it's like, whoa, why not? So to run your function based on a PL SQL, an index by collection, an associative array, what you have to do is call it locally, assign it to a local variable in your code, and then reference the collection instead, which is kind of a drag, but no big deal, I guess. Okay, same thing with object type. So I can create my object type, create my nested table on top of my object type. Now my function doesn't have any of the types in it because they're externalized into my schema level elements. So I create my package function, same thing there. So now I'm calling my constructor functions all down the line. And then notice in PL SQL itself, I can reference that data structure or the function. I don't have to assign it to a local variable. So that's one of the leftover inconsistencies from adding support for index by tables associative arrays for the table operator that came in 12.2, I believe. Okay. All right. So that's the basic idea. Now let's talk a little bit. Why don't you stop sharing my screen? So the bottom line is that you can treat a function as if it were a table. If it returns a collection, you can pass in parameters. You can return all different types of collections, associative array, nested tables, V-arrays. So you might be asking yourself, well, why would I do this? And there are a few really, really great use cases. So let's see. One of them is that, as I showed, you can actually merge in-session data with persistent data, whether it's a collection or a function returning that collection set. So that gives you a tremendous amount of flexibility. Another really great use case for table functions is when you're not so great at SQL. And I've mentioned this when we were talking about for all and bulk collect weeks ago, which is that if you have a row by row DML, so I've got a cursor for loop, and in the cursor for loop, I'm updating each row based on the primary key in that row that I fetched. That's a very slow operation, and you should switch to bulk using bulk collect and for all. Pardon me, let me get a drink. And you can go out online or in the SQL PL SQL forums at Oracle, and you can find really big SQL heads saying, you should not be using for all. Basically, if you're using for all, it's because you missed an opportunity to use SQL properly. And I don't generally disagree, though. There are some differences there are things you can do with for all you can't do with SQL. But in any case, in a lot of cases, you could have done it in SQL. But, we're not all Tom Kite, Connor McDonald, Chris Saxon, Kim Burke-Hansen, Tim Hall, et cetera, et cetera. My point being here that if you're really struggling to construct a data set appropriately in pure SQL, and you're good at PL SQL, you can always fall back on a table function to procedurally construct the data set that you then need to return. It's no dishonorable thing. You're getting your job done. Performance-wise, maybe not as fast as if you've done it in straight SQL, but that's not always that much of a big difference or not that much of a big deal. So a great use case for table functions is I need to get my job done, and SQL isn't cutting it for me, or I'm not cutting it for SQL. Another really great use case for table functions is parameterized views. Oracle does not support parameterized views. When you create or replace view, you don't have a parameter list. But if I'm saying select star from table function, then I essentially have a view that's built on top of that table function and the parameters in the table function. So you get parameterized view-like functionality out of table functions. Very cool stuff. All right, let's see. Do we have any questions? No. Once again, it's been a quiet group. Feel free to share your experiences with table functions. Has anybody used them, gotten really interesting value out of them? Another really good use case has to do with SmartDB. So probably a lot of you are aware of SmartDB. It is an architectural approach to building applications on relational database, and specifically Oracle, that says your application developers in general should not be writing any SQL, but it should be hidden behind a PL/SQL API. Now, I'll come back to that. Let me take a look at Nils's comment. But you must be aware of the fact that always the complete return collection must be created in memory before returning it to SQL unless you use the pipeline keyword. Great point, Neil. So what I decided to do for my talk today, notice it's already 11:15, and I like to keep my tips relatively short. I'm going to talk about pipeline table functions before we're done today, but I'm going to cover them next week. But since Nils raised the point, let me point out two problems with table functions as I presented to you before. In fact, let's go ahead and share my screen again. Obviously, when you're creating a table function, you're not going to be writing code like this. Let's construct a bunch of hard-coded values and stick them into the collection and return it. No, you're going to be building much more complex structures, much more complex data, probably even more data. You might have a table function that returns thousands of rows of data. Well, when you populate a collection inside PL/SQL, you're consuming PGA, process global area memory. And one of the best, and perhaps probably almost the only way that you're going to ever see your PGA memory blown out of the water and your user session affected is by making your collections too big. So one of the drawbacks of table functions that I've shown you so far is that they consume PGA memory, sometimes a lot of PGA memory. The other problem potentially with table functions when it's called from SQL is that when you call a PL/SQL program unit, everything that called it stops and sits there waiting until you're done and you return control. PL/SQL is not a multi-threaded language. So there's a serialization that occurs in SQL when it executes a table function or any PL/SQL function. Now, in general, that might not be a bad thing unless you're running a parallel query. So you're parallelizing, not parallelizing, parallelizing your SQL operations, basically cleaving them off into multiple parallel processes, then combining the data later. But if in your from clause you have a table function, boom. So much for parallelizing your code and your performance. So there's a special type of table function called the pipelined table function that addresses both of those concerns. It's a really, really interesting structure. And rather than try to throw it into the talk today, I thought I would save it for next week. And after that, we'll even have another session on an even stranger type of table function called polymorphic table functions. And I think I might invite my old friend, Chris Saxon from Oracle to join me and talk about that. All right, so let's see. I'm going to go back. If you could stop sharing my screen. Nils also points out if you use a record and collection defined in PL/SQL, Oracle always automatically creates object types and collections within the system with system-generated names for them. Thanks for pointing that out, Nils. I had forgotten about that. Great. Right. So I was talking about another use case for table functions now, which is SmartDB. There's also a variation of SmartDB called PinkDB. I won't go into all the details of this stuff, but the basic idea is that you want to avoid or minimize having application developers writing SQL. So for example, I'm writing a new procedure. It's implementing some business logic. If such and such happens, I need to insert into a table. So I'm going to type, if this, then insert into table. Bad idea. There should be a separate procedure, just one procedure in your entire application code base that does the insert into table X. And every developer, every program unit calls that same procedure. There are enormous advantages to taking this approach. One is that chances are you're going to do a much more robust implementation of that insert process because you're not just inserting, you got to check for errors, you got to deal with the errors, all sorts of possibilities. So you have one place where everybody goes, you can concentrate really good coding logic and bulletproof it there. And of course, from a security standpoint, restricting who and what can execute SQL is also very important. And for procedures, for non-query DML, inserts, update, deletes, it's pretty clear you call a procedure. But if you really wanted to avoid having application developers writing a lot of complex SQL, and having multiple references to tables, which in theory in SmartDB, they wouldn't even have select authority on. They wouldn't have access to any tables. Then what you would do is build a table function that hides the SQL, and it literally might be a select from table, and then you bulk collect that into your array and then return it or pipeline it, as we'll look at next week. But the point is that you will not have any privileges granted on those tables. The privileges are granted only to the underlying package or the schema that owns the package, therefore concentrating and controlling access, improving maintainability and security. So in a pure SmartDB environment, you would need table functions to essentially replace queries, though it doesn't completely replace queries because you're still going to say select from the table function, but everything else is pushed below. Similarly to a common recommendation, which is, in general, don't work against the underlying database tables, always work against views on those tables. It gives you a level of abstraction above them. You can change the underlying structures without necessarily changing your application code. So it's kind of like putting that layer on top of your tables, but this time with a function instead of a view. Okay, let's share my screen again. No more comments, right? Thank you, Nils, for all your great points. So in terms of resources for table functions, the blog post that we'll publish right after the session with the link to this video and so on has a number of resources listed there for you. What I did want to show you was Live SQL because there's just a lot of good stuff here. So if you search on table functions, first of all, you'll see a number of tutorials. So these are not individual scripts, but rather extensive tutorials that explain what a table function is, use cases for it, examples that you can try out yourself, and so on and so forth. Everything I've talked about today and way more. And those are actually built for a DevGym class. So if you go to the DevGym and look at the list of classes, you'll see Get Started with PL SQL Table Functions. So there are 5 modules based around those tutorials, plus videos, plus quizzes. All good resources to help you learn. In addition to the tutorials, you'll find specifics like table functions and ref courses, demonstration of streaming table function. Streaming table functions I'll also talk about next week along with pipeline table functions. Very interesting, and they don't require pipeline table functions, but they're most likely going to be worked on together. And also the polymorphic table functions added in 18C. Again, a much more complicated but really interesting use of table functions that I'll come back to hopefully in the future. So lots of different resources to explore here and try out. The DevGym class, Tim Hall has a page on table functions. Of course, I have several blog posts on it, so there's lots of information to find out about it. But the main thing is to just keep in mind that core idea, which is that if you can select from a table, why shouldn't you be able to select from a collection? If you can select from a collection, why shouldn't you be able to select from a function that returns a collection? The answer is absolutely, you should. Okay, so stop sharing my screen for a moment. Do we have any other comments? No. Okay. Feel free to put them in. Is this table function available in 11G or 12C? Absolutely. So table functions have been around for a long time. What you find with the newer versions is more and more applicability of the feature. So prior to 12C, associative arrays, the index by table structures, really couldn't be used for table functions except for pipeline table functions. Now it's more generally possible, though there are still some restrictions in the syntax. But they've been around for quite a while, and they're very solid. They're very stable in terms of the functionality. Okay, so to finish off for today, so that's the core of the PL SQL content. Feel free to ask questions, continue to ask questions, tell us about your table function stories, or ask about other PL SQL topics. But also now we're going to move on to showing you a few different organizations, and I'm going to ask Nils, because you had those great comments, to choose from the organizations I'm going to present today, and InSum will donate $25 to them. And then I'll share with you one of my favorite books, which Mark mentioned to me in advance. I might have done before, but I don't care. I really like it. All right, share my screen, please, Mark. So the 3 organizations I've picked for today, one is the same as last week because they're so important and they're so amazing. And my God, they're actually close to being extinct. Monarchs and other butterflies. So save our monarchs. Here's a different one. So Teacher Institute for Evolutionary Science. I think it's so important that humans in general, and certainly children, understand evolution by natural selection, how it works and how totally amazing it is. and why we should totally respect all forms of life and not think we're better than they are, but simply different. So I'm going to donate money to TIES, and maybe Nils will select that today. No pressure, no pressure. And Defenders of Wildlife. So this is an organization based in the US, and I think they're also active in Canada. And they do all sorts of work to defend wildlife, both species, ecosystems, and so on. And hopefully I'm going to start getting involved with Defenders of Wildlife here in North Carolina. But they're a great organization in terms of the sweep of the work they do, the kind of species that they support and protect. Just really incredible organization. So Nils, think about it. Do you want to save butterflies? Do you want to help the defenders of wildlife? Do you want to help teach evolution more effectively? It's up to you. And my book of the week. I hope I didn't do it before because I'd hate to bore you, but it's called Animal Architecture. Animal Architecture. And let's see, stop sharing my screen, please. Because I can then show you the book and show you some really amazing things. One of my favorite pet peeves about humans is that we think we're so exceptional. We do things that nobody else can do. For example, I shouldn't show you that yet. For example, we discovered evolution by natural selection. What other creature in the world could possibly do that? You know what? Lots of creatures could do it, because it turns out you don't even need advanced technology. You don't even need to know about DNA to understand and realize evolution by natural selection. But I won't go into that now. I'll talk about it maybe next time to not totally bore you or drive you away. But the other thing that people often say is, well, we're the only ones who do art. We're the only ones who modify our environment and build things. We're the only ones who do X, Y, and Z. And actually, other animals do almost anything that we do that's positive. We've got a bunch of unique negatives, like we're the only ones that poison water. Yeah, the source of all life. So here, for example, so if anybody ever tells you, well, we're the only ones who do art. Oh, wow, it's amazing. This is the nest, or it's not even the mate. It's not where they mate, but it's where they attract the mates. This is the nest of a bowerbird. Bowerbirds are simply incredible. They build these hallways to invite the females to come visit. And they have all this stuff they've collected and organized by color. And there are a variety of different approaches birds take. And basically the female will walk around, check it out, and decide if that male has what it takes to be their mate. And then they'll actually go off to the mating nest, which the female has built. So animals do incredible art. They build incredible large complex structures. Termite towers, for example, have built-in air conditioning and ventilation. They're much more sophisticated than we are. And they're so amazing. And the more you learn about them and the more you appreciate them, and the more you go outside and see it for yourself, the more you will take action to save what is left. And there's, boy, not much left at this point. So that's my favorite book. Check it out, Animal Architecture. Of course, you can just go online and read about animal architecture. There's a Wikipedia page and just go exploring. But it's also a really, really wonderful book. Defenders of Wildlife. Thank you. Thank you, Nils. We'll go with that. So that's my Feuer tip to today. Explore table functions. Explore them when you're struggling with your SQL. And I know I could just write it in PL SQL. I could build it programmatically. Just go ahead and do it. That's okay. Maybe you can add it to your to-do list to replace the table function with pure SQL later. Look for opportunities to do a table function. That way, to merge data, if you're finding yourself building some data in your procedure and then inserting it into a table just so you could join it with some other tables, again, the table function can help you there, and you can avoid the overhead and the coding of doing the DML to set up your temporary table. Lots of really great ways to use table functions, and lots of great ways to help heal the planet. So look for opportunities to put down your computer, put down your keyboard, go outside, do anything and everything you can to help your local ecosystems. If you want some ideas on how to do that, let me know and I will help you find opportunities where you live. I'm sure there are opportunities everywhere. So everybody, take care, stay safe. Please wear a mask whenever you go out and you're around other people, especially, obviously, indoors. We're lucky in North Carolina, we have a mask mandate for indoor activity. And I wish there was a mask mandate everywhere. What governors in Florida and Texas are doing are killing their children and making them sick. And it's an abomination that is hard to believe is being tolerated by anybody. But that's the world we live in. So don't do it to yourselves and your families and your friends. Get vaccinated, stay safe, take care. See you next week.